Hey everyone, my name is Paul, and in this video, I'm replacing the cylinder head in my 1997 Toyota RAV4. In the previous RAV4 video, I did some testing and found coolant leaking into the oil, which means I have a blown head gasket. Now if you're replacing the head gasket, you might as well put a fresh cylinder head in the car. Let's start by opening the hood. Yeah, that's boring, but check this out. I'm going to open it farther than normal. I'm hooking a motorcycle tie-down strap to the latch, then connecting it to the spare tire. This way, the hood won't just slam down when I bump into it. I don't even need the hood prop stick. I only need to lift the right front corner of the RAV4. The lower control arm mount is a good place for the jack stand. Take the right front wheel off using a 21mm socket. We will need access to the front of the engine. I'll be removing one of the engine mounts soon, so now is a good time to support the engine with the jack. I'll be disconnecting a lot of wiring, so taking the battery out first is a good idea. Take the negative terminal off first. If the wrench touches the body, I won't get a short circuit. Take the positive terminal off second. The battery hold-down bracket also takes a 10mm socket. The front hook will come out, but the rear hook stays. Now I can remove the battery. The battery tray has 4 bolts holding it in. I will definitely be washing this. Next step, remove the alternator. Unplug the connector, then use a 10mm wrench to loosen the power cable. Unclip the harness, then loosen the rear pivot bolt with a 14mm socket. Loosen the front pivot bolt with a 12mm socket, then use a drill to loosen the belt tensioner. Now the belt comes off. Take the front pivot bolt out, then the rear. Now pull the alternator up and toward the front of the car. Don't forget to take the belt off too. Next up is the power steering reservoir. Its function is to dump oil all over your belts. Pull it straight up, then unhook the rear hose. This will make a mess. It's a good idea to put a cap on the reservoir and plug the hose. Pull the U-shaped hose off the solid line in the car and remove the reservoir. Cap the line and clean up the extra fluid. Let's spend the next minute moving the wiring harness out of the way. Unclip the diagnostic port and the throttle cable. The alternator bracket has 3 bolts and takes a 14mm socket. Remove the ground cable from the strut tower. Now the bracket will come out. Don't forget the AC compressor clutch connector and the crank position sensor. The wiring harness is also clamped to the AC hose. Remove the 2 long bolts from the upper timing belt cover. Pull the wiring up and away from the valve cover. The engine mount is next. If you don't have a jack under the oil pan, add it now. The motor mount has 4 bolts and 1 nut that can be removed from above, and 1 more nut below. Lift it straight up and take it out. The support bracket is hard to take out. Use a shallow 14mm socket to remove the 3 bolts. This part is very annoying to deal with. Now just take it out. Just kidding, it's stuck in there. There's 1 more bolt holding the upper timing cover. Now we can get the cover and the motor mount bracket out. The power steering pump has some of the hardest to reach bolts. Toyota has a special tool for this, but it's not available. This mountain ratcheting wrench is perfect for the job. I used a shallow 14mm socket for the lower 2 bolts on the power steering pump. The upper bolt is very hard to reach. I ended up using a regular box and wrench. I'll go buy the special tool to put it back together. Now that I've loosened 3 bolts, I can push the power steering pump down and take the belt off. The harmonic balancer pulley comes off next. Toyota makes a special holder tool for this too, but if you have an impact wrench, you don't need it. Sometimes you can get the pulley off without any special tools. I was not that lucky. This is a harmonic balancer puller tool. I got it from AutoZone for $26. It comes with several bolts, so it works with different cars. Tighten the holding bolts, then the center bolt will remove the balancer for you. There are 4 more bolts holding the timing cover. The crank position sensor wiring is also clipped into this cover, so you'll need to unclip that. Now we have access to the timing belt. Let's remove it. Start by loosening the timing belt tensioner pulley. Notice it goes back up when I let go. There is a spring keeping tension on the belt. Hold the pulley down and take the belt off. This belt actually looks pretty good. There are no cracks or tears in the belt. I will install a new belt anyway. Working on the timing belt is very annoying, so you should always replace the water pump while you're in there. First, drain the coolant from the radiator. Toyota coolant is red, generic coolant is green. I recently discovered my head gasket may be blown because I'm using green coolant. Green coolant doesn't destroy gaskets, it's just that my car is too old and any small change like that will cause the gaskets to fail. This is the timing belt tensioner spring. This is the timing belt tensioner pulley. This is the timing belt idler pulley. Use a 10mm socket and remove 4 bolts from the water pump. There are 3 more bolts in the water pump that are easier to reach from the wheel well. The larger bolt holds the alternator bracket. Let's take that out. Now take the water pump out. I bought the cheap timing belt kit from AutoZone. It includes all the pulleys and a new water pump and housing. You'll get more life from original Toyota parts, but I don't care because I won't be driving this car much anyway. While we're here, let's check the timing belt tension spring. The manual says it should be 46mm long. The old spring measures 45.53mm. I guess that's good. I bought a new spring just to check, and it measures 45.50mm. Another thing that should be checked during the timing belt replacement is the oil pump. My oil pump is leaking behind the pulley. My front main seal is not leaking yet. Replacing the complete oil pump assembly requires taking off the crankshaft pulley and oil pan. I'm going to cheat a bit and replace only the seals that are leaking. The smaller part of the oil pump has 7 bolts holding it. Keep the bolts organized because 2 of them are shorter than the others. And the oil pump is off. You can pause the video here if you've lost track of your bolts. I replaced the jack under the oil pan with a jack stand under the drive axle. Now it's time to take the exhaust pipe off. Take 2 nuts and bolts out of the pipe just behind the engine and separate the front pipe from the back. There are 3 nuts holding the down pipe onto the manifold and catalytic converter. You have to turn the pipe and wiggle it to get it out. The exhaust manifold comes out next. Use a 14mm socket to remove 6 nuts. The stock manifold is cast iron and the bolts are harder to reach. It will also have a support bracket by the oil filter. Don't forget to unplug both oxygen sensors, and the exhaust manifold is ready to come out. This exhaust manifold gasket is made of 2 layers of metal. The plastic air intake box will come out of the car next. Unplug the intake air temp sensor, then loosen the hose clamp. Open the box and take out the air filter. The coolant overflow reservoir is kind of in the way, and it's easy to remove. The lower air box has 3 long bolts holding it down. There's a solenoid clipped onto the back of the box. Let's get that off. Loosen the hose clamp from the throttle body, take the hose off the valve cover, and this piece is ready to go. The distributor and spark plug wires come out next. Use a flathead screwdriver to pry the spark plug connectors up. Don't pull on the wires. Take the spark plug wires out. You don't need to disconnect them from the distributor cap. There is 1 bolt holding the distributor. Remove it and pull the distributor straight out. Remember to unplug the connector from the back of the distributor. Finally, unplug the coil wire. Next step, take the spark plugs out. I'm using a 16mm deep socket with a 6-inch extension. You can also use a spark plug socket. The spark plug socket has a rubber insert that holds the plug. I don't have that, so I'm taking them out with a magnet. This is a good time to inspect the spark plugs. All my spark plugs look pretty normal. They're a beige color, meaning it's not running too rich or too lean. The throttle cable is in the way, so that will be the next thing. Use 2 12mm wrenches to loosen the cable, then pull it out of the bracket. I coiled the cable up and put it out of the way on top of the cruise control. It's time to disconnect some coolant hoses. Start with the upper radiator hose. Twisting the hose will help break it loose. The next 2 hoses go to the heater and the throttle body. Take off the lower hose that goes to the front coolant pipe. Use a 12mm socket to remove 2 nuts from the coolant housing. Moving on to the front of the engine, the heat shield needs to come off. Now I have access to the coolant bypass hoses. They go to the oil filter housing. This is where the oil and antifreeze mix. Just kidding, my head gasket was doing that. I think this part helps cool the oil. Loosen the 2 nuts on the back of the water pump housing. There is 1 more bolt holding the pipe on the front of the head. Back on the transmission side, we have another big hose going to the heater core and a small one that goes to the throttle body. There is 1 more bracket on this side. Now the pipe is ready to come out. It has an O-ring and a gasket going to the water pump housing. Remove the lower radiator hose from the plastic thermostat housing. You can see the back of the thermostat here. Let's take 2 more nuts off and remove the thermostat housing. The thermostat has a large rubber O-ring to seal it. The throttle body is the next part to be removed. My RAV4 has a million vacuum hoses, so I'm marking them with different color Sharpies to keep track. Unplug the throttle position sensor, then pull 3 vacuum hoses off the throttle body. The big hose goes to the EVAP vacuum switching valve by the airbox, and the smaller hoses go to the EGR vacuum modulator. Use a 12mm socket to loosen the 4 bolts from the throttle body. Remember to unplug the idle air control valve. The lower bolts are longer than the upper bolts. I'm pulling off 1 more vacuum hose and the throttle body is ready to come out. Moving on to the right side of the car, there are a few more vacuum hoses to disconnect. Use pliers to loosen the 2 large vacuum hoses, then a 10mm socket to remove the ground cable. The fuel line going from the fuel filter to the fuel rail is next. Use a 17mm socket to remove the banjo bolt from the top of the fuel filter. The fuel line is round with a hole in the middle and it looks like a banjo. 2 washers seal the banjo fitting. Don't lose them. The exhaust gas recirculation valve is next. The EGR valve lets a small amount of exhaust back into the intake to reduce combustion chamber temperature and to reduce oxides of nitrogen emissions. The engine doesn't need EGR, but if you take it out, the check engine light will be on forever. Remove the 2 nuts from the back of the EGR valve and pull it away from the intake manifold to remove it. Don't lose the gasket. Now I'm working on the EGR vacuum modulator. These 2 hoses go down to the EGR vacuum switching valve. Take the vacuum modulator off with the bracket. Finally, there are a few more vacuum hoses on the back of the intake manifold. Pull these 2 hoses off the plastic vacuum filter. 1 hose goes to the manifold absolute pressure sensor on the firewall, and the other one goes down to the center locking differential. Let's get this bracket out of the way, and 1 more set of ground cables. Both take a 10mm socket. Remove the EGR vacuum switching valve. Normally this part is hidden under the intake manifold, but someone has moved mine to the firewall. The next hard-to-reach thing is the knock sensor. It's located on the back of the engine block under the intake manifold. You just have to reach back there and unplug it. I'll try to get the camera back here so you can see it. There it is. Now we can move on to the valve cover. Start by getting the throttle bracket out of the way. Then pull the hose from the PCV valve. Use a 30mm socket to remove the spark plug tube nuts holding the valve cover on. It's the same size socket as the axle nuts in the RAV4. Pull the valve cover straight up and wiggle it. You can pry it if you need to, but be careful not to scratch the sealing surfaces. The engine wiring harness is totally in the way, so it's getting removed right now. Take out this bolt from the intake, then move on to the firewall and start unplugging stuff. I realized while editing this video that you don't actually have to take the wiring off the firewall, but I already did it. You can pause the video if you need to identify components on the firewall. Release the 2 clips that hold the harness, then unplug the fuel injectors. I'm using a flathead screwdriver to help me unplug the connectors. Now pull the wiring that goes between the intake runners to the back of the engine. There's 1 more clip here, then move on to the inside of the car. Take out the right side kick panel and unplug this 1 connector. I couldn't release this clip, so I just cut it. Take out 1 more panel to gain access to the computer. There are 2 connectors above the computer and 2 connectors that plug into the computer. Push the big round grommet in toward the engine bay and pull the wiring harness out through the hole. Now I have this giant mess of wires. Move it out of the way, over here somewhere. With all the extra stuff finally out of the way, we can start working on the engine. The camshafts come out first. Use a 15/16 inch wrench to hold the camshaft and loosen the cam pulley bolt. Take out 3 more bolts and remove the timing belt backing plate. The valve springs constantly push on the camshaft, so it's important to turn it to a point where the pressure is even. The Toyota engine service manual says to have the knock pin between 10 and 45 degrees before top dead center. They give you a range, but the best position is exactly 27.5 degrees. The camshaft wants to snap into the 45-degree position. You'll feel resistance when you turn it past 27 degrees, then it will snap into the 10-degree position. You want to go back and find the spot in the middle at 27 degrees. If you look closely at the exhaust camshaft, you'll notice the gear is actually 2 gears next to each other. I don't know why it's like that, but you need to lock them together with a bolt. I used a timing cover bolt for this. Next, we'll be removing the cam bearing cap at the end. Use a 10mm socket to remove the bearing cap on the transmission side of the exhaust camshaft. The camshaft bolts should be loosened a little bit at a time in the correct sequence to prevent the camshaft from getting bent during removal. The engine service manual says to loosen the bolts in several steps, but I think 2 steps is enough. Don't touch the bearing cap with the X at the moment, and remember the intake camshaft should be at 27 degrees before top dead center. Once the bolts are loose, remove the 3 bearing caps. Only the number 3 exhaust bearing cap is left now. If the camshaft turned at all, reinstall the bearing caps and make sure the intake camshaft is at 27 degrees before top dead center. Now loosen the bolts a little bit at a time. The camshaft should lift up evenly on both sides as you loosen the bolts. Remove the exhaust camshaft. The intake camshaft is next. The engine service manual says to set the knock pin between 80 and 115 degrees before top dead center. Between means exactly 97.5 degrees. The valve springs will make the camshaft snap into the 115 degree position. As you turn the camshaft, you'll feel resistance and it will snap into the 80-degree position. Go back and set it exactly halfway between at 97 degrees. The bearing cap on the timing belt side comes off first. Take 2 bolts out and remove the cap. Pull it straight up with some big channel lock pliers. The intake camshaft bearing caps need to be loosened in several passes in the correct sequence to prevent damage to the camshaft. Double check to make sure the knock pin on the timing belt side is at exactly 97 degrees before top dead center and loosen the bearing caps a little bit at a time. Don't touch the bearing cap with the X. The bearing cap by the number 2 spark plug is the only one holding the intake camshaft now. If you look closely at the fast forward video, you'll notice the camshaft lifts up evenly on both sides as I loosen the bolts. Remove the bearing cap and the camshaft. Lay the camshafts and bearing caps on a piece of cardboard in the same order as they were in the engine. If you didn't do that, it's okay. Toyota idiot-proofed the bearing caps by stamping numbers into them. Pause the video here if you need to organize your parts. With the camshafts out, I finally have access to the head bolts. The cylinder head bolts must also be loosened in several passes in the correct sequence. If you don't follow the steps, the head can get warped or bent slightly, and the new head gasket will leak. The head bolts take a 12mm 12-point socket. Loosen the bolts a little bit at a time, following the sequence on the screen. I loosened all 10 bolts about halfway loose with my wrench in the first pass, and almost completely loose in the second pass, also with the wrench. I did the final loosening with my impact wrench and pulled the bolts out with a magnet. You can't see it in this video clip, but the 8th and 10th head bolts have a lot of sludge buildup on the threads, and the other bolts are clean. This is because the head gasket was blown and allowed coolant to run down into the oil pan and get on the bolts near the drain holes. Finally, the cylinder head is ready to come out. Lift straight up. You can pry on it a little bit if you need to. Oh, and it's stuck. It looks like I forgot something. I missed one bolt on this stupid metal vacuum line on the back of the intake manifold. When you're turning your steering wheel in the parking lot, a pressure switch on the bottom of the power steering pump opens and creates a vacuum leak. A little bit of extra air in the intake manifold increases your idle RPM to help with the power steering. It's silly and the car doesn't need this part. Also, the EGR vacuum switching valve is poorly placed right here where you can't reach it. Relocating the VSV is a common upgrade on the RAV4. Earlier in this video, you might have noticed my VSV was already moved to the firewall, but whoever did it just left this one here, so I have 2 of them. That's it. Now the cylinder head is out of the car. Next, I'll be taking the intake manifold off the cylinder head. Remove the wiring harness holder. This is the EGR VSV. The intake manifold has 2 nuts and 6 bolts holding it on. Now it just slides off. My cylinder head has this weird air hose here, and the fuel rail is held on by 2 long bolts. And now I can take the fuel injectors out. Don't lose the 2 plastic fuel rail spacers. Let's take a look at the old head gasket. The 3 large holes in the back are oil drains from the head down to the oil pan. The seal is broken between the drain and the head bolts, which is not a big deal, but check out these bolts. That sludge happened because the oil was contaminated with coolant and it leaked onto the head bolts. Let's pull this old head gasket off the engine. And yeah, it looks really bad. The 3S FE engine has a cast iron block, so it's okay to clean it with a brass wire wheel. Brass is softer than iron, so it will clean off the gasket material, but it won't scratch the metal. I used a wrench to rotate the engine so I can clean the other 2 pistons. Don't use the wire wheel to clean the aluminum cylinder head. If you're reusing the old head, clean it with a nylon brush and carefully scrape it with a razor blade. Now that the engine block is clean, let's take a look to see what happened to it. Pressurized oil comes from the oil pump and enters the head through 1 small hole on the right corner. The 3 large holes in the back are drains that allow the oil to get back to the oil pan. Most of the holes in the block are for coolant. The head gasket must keep all these holes separate from each other. A closer look at the problem area will reveal pitting near the oil drain holes. This is a little strange since oil doesn't normally corrode metal. Oil that is contaminated with coolant becomes acidic and can eat away at the metal. This is what happened here. I might be wasting my time replacing only the cylinder head because the engine block needs to be removed from the car so the surface can be machined to remove the pitting. I'm not doing that, so I'm hoping the flat areas around the coolant passages will be enough for the head gasket to seal. There is a chance my new head gasket will fail. Also, why isn't there pitting between the oil drain and coolant passages? The leak must have been on the cylinder head side of the gasket. This is the top of the head gasket. Notice the oil inlet hull is on the right. The rings around the combustion chamber are intact, but the holes around the oil drains are broken. Upside down, the head gasket looks about the same, and it's hard to tell where the coolant was leaking. The stains on the cylinder head reveal what happened. My RAV4 had red coolant its entire life until I changed it to green and installed an AutoZone radiator cap that didn't fit the radiator and did not limit pressure. The coolant pressure would just go up and up and up until my radiator broke, a couple coolant bypass hoses started leaking, and the head gasket started mixing coolant and oil. You can see the red coolant was leaking a little bit, but the green coolant leaked a lot, especially near those 2 big oil drain holes at the top of the picture. On the right, I have the new cylinder head. It's time to compare the parts to make sure the new one is the same and to swap over some studs and the oil pressure sensor. But wait, these heads are not the same. The head that came out of my car has a port going to all the fuel injectors with a hose in the middle, and the new head does not. The fuel injectors just go directly into the intake ports. On the timing belt side of the engine, my head has the letter C and the other head has the letter B. On the exhaust manifold side, the heads look exactly the same. And on the distributor side, they are also the same. The combustion chamber side also looks the same on both heads. After doing a little research, I found out I have the California emissions cylinder head in my car. I ordered the wrong part. You can find out which head you need by looking at the emissions label under the hood. Here it is. My emissions label says this RAV4 is not for sale in California. I entered my VIN into vindecoders.com and it also didn't say anything about California. The VIN on my engine matches the body. So why does this non-California emissions RAV4 have the California emissions cylinder head? My theory is Toyota built this RAV4 on a Friday and they just slapped in whatever engine happened to be on the shelf that day. Anyway, I went back to AutoZone and I ordered the other cylinder head, waited a couple weeks, and then found out the California emissions head is not available through the remanufacturer. Fortunately, they still had the normal head, so I took that back, and I think the only difference is the fuel injectors. So if I get the normal injectors out of another RAV4, I could use that cylinder head. So I got the fuel rail and injectors out of this 99 RAV4 at the junkyard. This one looks like it does not have the California emissions head, so I'm hoping these injectors will fit the new head that I got for my RAV4. Back in the garage, let's talk about California emissions a little bit more before I put this thing back together. The California engine has air induction injectors. The holes on the end of the injector are bigger than on the normal fuel injector. The area between the O-ring and big rubber seal goes to a port in the head that has air. Air and fuel can pre-mix inside the fuel injector, which would theoretically give the car better gas mileage or cleaner emissions. My theory is it does nothing except make it a pain in the ass to buy parts. Air comes in through this big hose. It is not a vacuum hose. This hose connects below the idle air control valve and takes air from in front of the throttle plate. The hose connected above the throttle body goes to the evap vacuum switching valve. The other big hose, also not vacuum because it connects in front of the throttle plate, goes to the power steering idle up. That's the annoying metal tube bolted to the back of the intake manifold. The federal emissions head does not have the air passage for the fuel injectors, and there is no hose. The port on the side of the throttle body is not used, and the port by the idle air control valve connects to the power steering idle up instead. These hoses allow a small amount of air to bypass the throttle plate while you're turning the steering wheel. I'm going to delete this feature. Two vacuum hoses connect to the power steering pump, and the metal line bolts to the intake manifold. This stuff belongs in the trash. That looks a lot better. I'm just going to plug these two ports in the throttle body. I'm not using the California head, and I'm deleting the power steering idle up. We're about halfway through this video, so I'll give you a satisfying before and after view of all the parts. It's like switching out your old black and white TV for one that has colors. It's time to move some parts over from the old cylinder head to the new one. The oil pressure switch takes a 27mm socket. The decorative cap fell off. You don't need it. Use a little silicone sealer on the threads. The oil pressure switch has tapered pipe thread, so it's very easy to cross thread. Look at it from the side to make sure you're screwing it in straight. Don't let the large socket fool you. This switch doesn't need to be very tight. Over-tightening can crack the head or break the switch. Next, move the EGR fitting over to the new head, also with some silicone sealer. It's okay to tighten this one a lot. I need to move the intake manifold studs, thread on two nuts, and tighten them against each other. Turn the inside nut counterclockwise to remove the studs. Now thread the studs into the new head and tighten to 14 foot-pounds. Turn the inside nut clockwise to break the nuts loose from each other. They should come off easily after that. The water outlet studs also have an 8mm by 1.25 thread pitch. Move them over to the new head and tighten to 14 foot-pounds. Break the nuts loose and take them out. Did the remanufacturing place tighten this plug? Maybe. Take it out, add sealant, and make it very tight so you don't end up with any surprise leaks. You'll need to move two half-circle caps over to the new cylinder head. Use a brass wire wheel to remove the old silicone sealer. I'll install these later. The end cap needs some sealer. This is where the distributor goes in. This cap is not very clean. There's some black stuff that won't come off with alcohol. I'm using Goo Gone and a plastic scraper to clean it up. This is where the distributor O-ring goes, so the surface needs to be smooth. You don't want to add scratches with a screwdriver or wire wheel. Add a thin coat of silicone sealer to the flat surfaces and reinstall the cap. Tighten to 14 foot-pounds and wipe off the extra silicone. I bought some new exhaust studs from Toyota Parts Deal, and I'm using the same technique with two nuts to tighten the studs. Turn the inside nut clockwise to break them loose from each other. If you turn the outside nut counterclockwise, you might loosen the stud. Okay, this part is annoying. We've already removed the camshafts once, and now we're doing it again. Use a 15/16" wrench to turn the intake camshaft to 27 degrees before top dead center. This is the best position to remove the exhaust camshaft. The exhaust camshaft gear is actually two gears next to each other. Install a bolt to hold them together. The remanufactured head came with the service bolt installed. The bearing cap on the end comes off first. Break the bolts loose, then remove the cap. Next, I'm removing bearing caps 1, 2, and 4, and leaving cap number 3 for now. Loosen the bolts a little bit at a time, following the sequence on the screen. I loosened each bolt twice by hand, then did the rest with my impact driver. Now just take the bearing caps off and keep them organized. It's time to remove the number 3 bearing cap. Loosen the bolts a little bit at a time to keep the bearing cap straight. The camshaft will get pushed up by the valve lifters as you loosen the cap. Remove the exhaust camshaft. Use a 15/16 inch wrench to turn the intake camshaft to 97 degrees before top dead center. The cap on the end of the camshaft comes off first. Use a 10mm socket and loosen the bolts evenly on both sides. Grab the cap with big channel lock pliers and pull straight up. Next, I'm removing bearing caps 1, 3, and 4 and leaving cap number 2 for now. Loosen the bolts a little bit at a time to make sure the caps come off evenly. Follow the sequence on the screen and don't touch the number 2 bearing cap yet. Remove the caps and remember to keep your parts organized. Finally, the number 2 bearing cap needs to be removed from the intake camshaft. Loosen the bolts a little bit at a time. The camshaft should be pushed up evenly on both sides by the valve lifters. And that's it! The camshafts are out. The cylinder head is ready for fuel injectors. I picked up the lower fuel injector seals from my local Toyota dealer. The other 2 seals were included in my head gasket set. Don't reuse the old seals. They're not good. I'm applying dielectric grease to the O-rings so they slide in easily and don't get damaged during installation. Press the fuel injectors into the fuel rail, then install it on the cylinder head. Install the plastic spacers, then torque the bolts to 9 foot-pounds. That's not very tight. The intake manifold is much easier to install while the head is out of the car. The Felpro head gasket set includes the intake manifold gasket. The intake manifold has 6 bolts and 2 nuts holding it on. Start them all by hand, then lightly snug them down. Torque the bolts and nuts to 14 foot-pounds. My digital torque wrench beeps when you reach the right torque. This next step is very important. Head bolt torque is the most important specification in the whole car. If the bolt is hard to turn because the threads are dirty, you won't be able to torque it correctly. You'll end up with loose head bolts and a head gasket that won't last very long. My head bolt threads are super dirty. I'll start by scraping a little sludge out with a screwdriver, then blowing the hole out with compressed air. Then I'll fill it with a light lube. Use a 10mm by 1.25 tap to chase the threads. Start the tap by hand and make sure it's going in straight. The end is tapered, so it's possible to destroy your threads if you're not careful. Slowly turn the tap and add oil as you go. Halfway through, I removed the tap and cleaned off the dirt it picked out of the threads. Put the tap back in, and this time I'm going all the way down. You should feel it stop when it reaches the bottom of the hole. Take the tap out and clean the hole again. That looks much better. Check the depth with a screwdriver, then tape a bolt with the same amount of threads exposed. You should be able to thread it all the way in by hand without any tools. If the bolt is hard to turn with your fingers, you need to chase the threads again. Now is the part we've all been waiting for. It's time to install the cylinder head. Clean the engine block with alcohol and a microfiber towel. Install the head gasket and make sure the oil passage lines up on the lower right-hand corner and you can read the letters 3SFE. Clean underneath the cylinder head. Don't put the head upside down because the lifters and shims will fall out. Then you'll have to re-shim all the valves by installing the camshafts and using feeler gauges to figure out where all the shims go. It's a horrible puzzle that isn't fun. Gently set the cylinder head on top of the engine and wiggle it to make sure it's in the right position. Dip the threads of your brand new head bolts in motor oil. This will make the bolts turn easily and consistently so you can get an accurate torque measurement. Notice the sequence I'm installing the bolts in. As you tighten the head bolts, you want to apply pressure to the middle of the head and work your way out to the edges. This is the page from the Toyota service manual that tells you how to install the head bolts. Snug all the bolts down by hand. If any of them don't turn easily, take the cylinder head off and clean the threads again. The bolts should be tightened in steps. The first time around, I'm tightening the bolts to half torque. Make sure you're following the green numbers on the screen. The second pass, I'm tightening the bolts to full torque, 36 foot-pounds. Watch the display on the torque wrench and don't go over 36. My wrench also beeps when you reach the correct torque. Now that all the bolts are tight, there is more pressure holding the cylinder head down, and the first bolts are a little bit looser. Go back and torque them all to 36 foot-pounds again. Hold constant pressure on the torque wrench as close to 36 as you can until the bolt doesn't turn. The head bolts in the 3SFE engine are torque to yield bolts. That means they get stretched during installation. This is why you must always use new bolts for the cylinder head. After torquing the bolts down, they need an additional 90-degree turn to finish tightening them. Mark the top of each bolt with a line facing the back of the car. Use a permanent marker or paint pen. I'm using a torque angle gauge with a breaker bar to turn each bolt exactly 90 degrees clockwise. The bolts will be very hard to turn. You must apply constant pressure and don't turn it past 90 degrees. Tighten the bolts in the same sequence as before. Take your time. This is the most important step of the cylinder head installation. This torque angle gauge was $35 on Amazon. Just go buy one, or make something out of cardboard. But whatever you do, don't just guess what 90 degrees is when you turn your wrench. Okay, you get the point. I'm going to fast forward the video a little bit here. Torque the bolts properly, or your new head gasket will blow up. Once you're done, make sure the marks on your head bolts are pointing exactly 90 degrees to the right. The camshafts go in next. Apply assembly lube to the intake camshaft bearing journals and lifters, then gently set the camshaft down. Add assembly lube to the inside of the seal, then slide it over the end of the camshaft. Make sure the seal is pressed all the way in and the camshaft knock pin is at 80 degrees before top dead center. Just turn the camshaft a little until the seal sits as low as possible. Add assembly lube to the top of the camshaft, then apply a thin coat of silicone sealer to the end cap. Install the intake camshaft bearing caps and make sure the arrows are pointing to the timing belt side of the engine. Next, we will be tightening the camshaft bolts. Apply motor oil to the threads. All the bolts are the same, so it doesn't matter if you mix them up. The bolts need to be tightened a little bit at a time, following the same order as the green numbers on the screen. The goal is to push the camshaft down evenly. You can tighten the bolts in several passes if you need. Once all the bolts are snug, go back and torque each one to 14 foot-pounds. The torque wrench will make a solid tone once the proper torque is reached. Keep pressure on the wrench at exactly 14 foot-pounds until the bolt doesn't turn. This next part is tricky. The camshaft gears need to mesh at exactly the right position. There is a small timing mark on both camshafts. The confusing part is each camshaft has 3 marks and only one of them is correct. There's a mark on the intake camshaft, but that's not it. The second mark is the timing mark and the third one is not, so it's the one in the middle. Out of the 3 marks on the intake camshaft, the middle mark is the one you want. It's closer to the mark on the right. The exhaust has confusing marks too. We'll get to that soon. Next, the intake camshaft will need to be turned so it's between 10 and 45 degrees before top dead center. 27 degrees before top dead center is the perfect position for this step. Apply assembly lube to the bearing journals and valve lifters for the exhaust camshaft. Mesh the gears together so the timing marks line up and roll the exhaust camshaft down. Here's another look at the service manual. You can pause the video here if you need. The exhaust camshaft also has 3 marks. The second one to the right of the service bolt is the timing mark. Here's a good close-up. My gears look just like the picture. Turn the intake camshaft a little bit if you need to make sure the exhaust camshaft sits evenly on the number 2 and number 4 lifters. Notice the number 2 cam lobes are pointing to the back of the car and the number 4 lobes are pointing to the front. Add assembly lube to the exhaust camshaft. Install the bearing caps and make sure the arrows point to the timing belt side of the engine. The exhaust camshaft bolts must also be tightened in the correct sequence to prevent the camshaft from getting bent during installation. Remember to dip the bolts in engine oil before you install them, then tighten each bolt a little bit at a time, following the same order as the green numbers on the screen. Finally, the exhaust camshaft bolts need to be torqued to 14 foot-pounds. I'm using the Harbor Freight Quinn 3/8" drive digital torque wrench. It costs $160 and it's awesome. Turn the intake camshaft so you can see the timing marks on the gears. If they don't line up, you must reinstall the exhaust camshaft. Remove the service bolt from the exhaust camshaft gear. Before we forget, there's a bracket behind the intake manifold that needs a bolt. It's behind the intake, right in the middle. The bracket goes between the engine block and intake manifold and gives a little extra support. Now is a good time to replace those old heater hoses. Use a 10mm socket to remove the bracket, then remove the hose clamps with pliers. This hose came off easily. The heater hoses on the RAV4 are 5/8 inch inside diameter. The shorter hose is on the transmission side of the engine and measures 26 inches long. Do you see what I'm doing here with the pliers? Don't do that. The heater core outlets are soft aluminum and pliers will crush the pipe. Use a knife to cut the old hose off instead. Okay, I unsquished the pipe and I'm installing a 30-inch piece of hose on the side closer to the timing belt. Reinstall the bracket and this part is done. Since we're working on stuff by the firewall, I'll hook up a couple more vacuum hoses back here. This part is called the vacuum filter. Add some sealant and don't make it crazy tight. The map sensor and center locking differential vacuum hoses will connect to the intake manifold here. Moving on to the timing belt side of the engine, there's a bracket and a ground wire back here. This big 3/8 inch diameter vacuum hose goes to the brake booster. The smaller line on the intake was for the power steering idle up. I'm not using that, so I'm installing a 1/4 inch plug here. The oil pump goes back in the car next. This seal was leaking, so I'm replacing it. You can use the old seal as an installation tool. Be very careful to make sure the seal goes in straight. Add some assembly lube to the seal, and all the parts inside the oil pump need to be lubed too. The pulley goes on next. I made a tool to hold the pulley while I tighten the nut. Add some assembly lube to the oil pump rotor and install it on the engine. Silicone sealer will hold the rubber seal in place while I install the oil pump. If the seal tries to fall out, add more silicone. Now just install the oil pump. Start the bolts by hand and pay attention to where the short and long bolts go. These bolts get tightened to 5.9 foot-pounds. I'm using my imaginary torque wrench this time. It doesn't matter what order you tighten them, but it's a good idea to check each bolt twice. Remember how I said the oil is bad? Let's drain it and see what it looks like. It's pouring out very fast, like the viscosity is too thin. Reinstall the drain plug and torque it to 30 foot-pounds. Okay, and the bottom of this pan has some nasty stuff. That's oil mixed with coolant right there. The F-cap oil filter wrench is the best tool for removing the oil filter on your RAV4. Wipe some oil on the O-ring of the new filter and get it as tight as you can with one hand. Don't use tools to tighten the oil filter. I'm shoving a funnel into the center oil drain in the back of the cylinder head. The oil will go straight down to the oil pan. Pour in 4.5 quarts. It's a good idea to prime the oil pump. I can pressurize the oil system now, so when I start the engine, I will have oil pressure right away. The oil comes into the head on the right, passes by the oil pressure switch, then goes through the camshafts. There's still a little bit of contaminated oil in the system, but it's mostly new oil. The water pump is next. Apply a thin coat of silicone sealer to both sides of the water pump gasket. You can install the gasket without sealer, but I want to make sure it won't leak. Now just install the water pump onto the housing. There are 3 bolts that hold it together. This is where the shorter water pump bolts go. This water pump came with the AutoZone timing belt kit and includes new studs. Install 2 nuts on the stud and tighten them against each other. Turn the outside nut clockwise to install the stud, then turn the inside nut clockwise to loosen the nuts from each other. This method of installing studs is good because you won't damage the threads and you can use a torque wrench to tighten them just right. Install the O-ring on the thermostat, then put it in the plastic thermostat housing. Add 2 nuts and tighten them to 5.9 foot-pounds. The shorter studs that came with the water pump go here. This port goes to the coolant pipe in front of the engine. Generously apply silicone sealer to the round hole in the back of the water pump and install the O-ring. You don't want this O-ring to fall out during installation. Gently move the water pump into position and start the 3 long bolts by hand. Tighten the bolts evenly, a little bit at a time. Check each bolt at least twice to make sure they are tight. The big bolt goes on the lower right corner of the water pump and holds the alternator bracket. Install the lower radiator hose and the water pump is done. The coolant bypass pipe runs in front of the engine and connects the water pump to lots of other fun stuff. Cover both sides of this gasket with silicone, then install it on the water pump housing. The gasket and this O-ring both came with the timing belt kit. I used dielectric grease to help the O-ring slide in place without getting damaged. Now just install the coolant pipe. It was actually very hard to push it into the water pump because the studs were catching on the flange. I got it in most of the way, then used the nut to pull it in. The lower nut is much easier to reach with the oil filter removed. Tighten both nuts to 6.8 foot-pounds. That's tighter than the water pump bolts and thermostat housing nuts. Reinstall the oil filter, and don't forget about the 2 bolts that hold the pipe onto the head. The water outlet connects the cylinder head and upper radiator hose. This gasket came with the Fel-Pro head gasket set. Install the water outlet and tighten the nuts to 11 foot-pounds. Next, I'll be connecting coolant hoses. You can use 5/8 inch hose from the auto parts store here, but the molded hose from Toyota is less likely to kink, especially since it's short with a 90-degree bend. Don't forget to connect the upper radiator hose. The hoses in front of the engine are 1/2 inch diameter. They can be substituted with auto parts store hose, but the original parts are still available from Toyota Parts Deal. Don't forget about the heat shield. You don't want the coolant hoses to get melted by the heat coming off the exhaust manifold. Okay, maybe they won't melt, but you'll definitely shorten their life if you skip the heat shield. It's time to install the engine wiring harness. Just throw it in there. That's good enough, right? Start by feeding the computer end of the harness through the firewall. 1 connector goes to the right kick panel, 2 connectors plug in above the computer, and 2 go into it. Reinstall the panels and add some zip ties to hold the wiring harness up out of the way. Okay, and we're all done inside the car. Clip the wiring harness into the intake manifold, then plug in all 4 fuel injectors. There is 1 bolt holding the wiring onto the manifold here. Moving on to the firewall, plug in the igniter, the vapor pressure sensor, the coil, and the ignition noise filter. On the other side of the firewall, you have the map sensor and differential vacuum valves. Right now is the perfect time to plug in the knock sensor behind the engine block and connect the engine ground behind the intake manifold. Both these wires are routed through the middle of the intake manifold. 1 more nut holds the harness below the water outlet pipe. The 3-wire connector on the transmission is the vehicle speed sensor. The 2-wire connector next to it is for the center locking differential. The starter bolt also holds the wiring harness. Plug in the coolant temperature sensors and the oil pressure switch. Connect the starter terminals. This solenoid is for the evaporative emissions. Connect the engine wiring harness to the relay box. Tighten 2 nuts and plug in the connector. The heater hoses go in next. The longer hose is on the engine side of the car, and the shorter hose is on the transmission side. Be careful not to buy cheap heater hose. I grabbed a bag of heater hose at the auto parts store for $6 and realized it didn't fit right. The inside diameter was too small and I had to stretch the hose a lot. The slightly more expensive hose had the correct inside diameter. I removed the heater hose bracket from the firewall to give the hoses a straight path so they won't kink, and added some protection where the hose touches the brake line bracket. EGR stands for exhaust gas recirculation. The EGR valve takes a small amount of exhaust gas and recirculates it back into the intake manifold to reduce combustion chamber temperature. This reduces oxides of nitrogen emissions. I love the way car parts are named. They just make sense. This is the EGR vacuum modulator. It has 3 vacuum hoses on top and 1 below. Don't forget to plug this extra port on the manifold with a 3/8 inch vacuum plug. The throttle body is next. I'm using a little bit of silicone sealer to hold the gasket for me. Make sure to install the long coolant hose on the left side of the throttle body, and the short hose goes on the right. My throttle body has 4 bolts. The short bolts go on top, and the long bolts go below. I used a torque wrench here, but you don't have to. Plug in the EGR vacuum hoses, then the idle air control valve and throttle position sensor. The shorter hose connects to the water pipe closer to the engine, and the longer hose connects to the water outlet. Next up is the fuel hose. Install 1 washer above the banjo fitting and 1 below. Use a 17mm wrench to tighten the hose onto the fuel filter. Let's get that distributor back in the car. The old O-ring is hard and broke as soon as I touched it. Let's replace that. I'm adding a bit of dielectric grease to help it during installation. The dust seal keeps water out of your distributor when you're driving through big puddles or pressure washing your engine. Now just slide the distributor in place. Don't worry, it's idiot proof. It doesn't fit if you put it in wrong. Install the bolt and tighten it down, and don't forget to plug in the connector. The valve cover will make it look more like a car. Let's install it. Remember these half circle things? Add silicone and install them. Make sure to add sealant in the corners where the distributor camshaft cap meets the cylinder head. The valve cover gasket is rubber and does a great job, but it can use a little help in the corners. Install the timing cover backing plate next. 3 short bolts hold it in place. You should be able to feel if a bolt is tightened the right amount. If you can't do that, have a mechanic fix your car for you. The cam gear goes on next. Use a 15/16 inch wrench to hold the intake camshaft while you torque the bolt. The valve cover doesn't need silicone sealer, but a little bit will help hold the rubber seal during installation. Install the valve cover. I had to push the wiring harness out of the way a little bit on the timing belt side. The spark plug tube seals fit loosely on the inside, so I'm adding just a little bit of silicone here. Use a 30mm socket to tighten the nuts. It's the same size socket as the axle shafts on the RAV4. Now for the infamous EGR vacuum switching valve. This is the electronic part that allows the computer to control the EGR valve. Toyota put it in a stupid, hard to reach place. We're going to fix that right now. I'm installing the throttle cable bracket upside down behind the VSV with the same bolt. You can reuse the vacuum hose that was attached to the VSV. The middle of the hose should still be good as new. You need 8 inches to reach the vacuum modulator and 15 inches to reach the EGR valve. PCV stands for positive crankcase ventilation. As the engine runs, a little bit of air and fuel get past the piston rings into where the oil is. The PCV valve opens to send the extra vapors into the intake manifold. If the PCV valve doesn't work, pressure can build up, causing your engine to leak oil. Let's get a few of these brackets back on here, starting with the throttle bracket. It has 2 short bolts. Tighten them with a 12mm socket. This is a hook for when you remove or install the engine. I got a new spark plug wire holder from Toyota Parts Deal. The distributor cap goes back in next. If you have a newer RAV4, you'll be installing the coils right here. You should install a new distributor cap and rotor and spark plug wires. I'm leaving the spark plugs out to make it easier to turn the engine while I install the timing belt. Plug in the coil, and that part is done. The plastic air intake stuff goes in next. This part takes cold air from behind the headlight. Don't forget to plug in the switch just behind the starter. It's for the reverse lights. The air box goes in next and has 3 long bolts holding it down. Make sure both vacuum switching valves for the evap system are plugged in. The charcoal canister stores gas that evaporates from your fuel tank on a hot day, then the valve by the air box lets you burn those fuel vapors. A 15-inch long hose connects it to the throttle body. The air filter goes in next, followed by the top part of the air box. Don't forget to plug in the intake air temperature sensor. The coolant overflow reservoir clips into the lower air box and has 1 bolt holding it on. When the engine warms up, the coolant expands and the tank catches extra coolant that doesn't fit in the radiator. When the engine cools down, that coolant goes back in the radiator. This piece of hose goes from the air box to the charcoal canister. I cut the new piece longer than the old one to prevent it from kinking. The weird box on top of the intake tube is a silencer. Engines actually make a lot of noise on the intake side. You can use an electric impact driver to tighten the hose clamps if you're lazy, but the final tightening should be done by hand. This hose lets clean air into the valve cover. It's part of the positive crankcase ventilation system. The fuel hose I used wasn't flexible enough to fit over the barb, so I cut it off. It was a very tight fit. No hose clamps needed. The exhaust manifold is next. This gasket came with the head gasket set. I have a weird exhaust manifold. It's for a Camry and I modified it to fit my car. Sometimes I do stuff the hard way. Watch episode 9 if you want to see what I did. Torque the exhaust manifold nuts, starting in the middle and moving out. Check them twice. Remember to plug in both oxygen sensors. The exhaust downpipe is next. The pipe goes above the subframe. You'll need to twist and wiggle to get it past the sway bar. The Felpro 23626 is the best exhaust gasket. The Toyota service manual says to torque these nuts to 46 foot-pounds. That's really high. It will completely crush the gasket. That's okay, but 35 foot-pounds would be enough. The back of the pipe takes the same gasket and the same nuts. Tighten them a little bit at a time so things stay straight. The torque spec on these bolts is 35 foot-pounds. Are you ready to do the fun part where you can mess up your engine? That's a lie. It's not fun and you can't mess up your engine. The 3SFE engine is non-interference, meaning the valves won't hit the pistons if you install the timing belt wrong. I'm making a little more room to work by moving the power steering pump line. Use a mirror to look through the hole in the cam gear. It's too bad that hole is too small and you can't see through it. Okay, I just used a stepper bit and drilled the hole out. Mark the 12 o'clock position and reinstall the cam gear. The valve cover is already on, so I'll need to use this tool to hold the cam gear while I tighten the bolt. That's much better. Now I can actually see. Center the hole on the mark at the top. Turn the engine over by hand until the timing mark lines up with top dead center. Follow the tooth to the left of the pin, then look at the slot to the left of that. There's a small notch in it. That's the top dead center mark. Install the timing belt idler pulley and torque the bolt. Clip the spring into the tensioner bracket. The tensioner pivots on a pin sticking out of the head, then the bolt goes in. Push down on the bracket with a pry bar, then tighten the bolt. This will make it so there's no belt tension. Install the timing belt around the crank pulley and oil pump and inside the idler pulley. Jam a socket below the crank pulley to hold the belt. The belt goes around the front of the water pump, then pull it tight as you install the belt on the cam gear. Hold the belt on the cam gear as you push it over the tensioner pulley. Keep holding the belt until you loosen the tensioner bolt. Now the spring will hold the belt for you. Turn the engine clockwise exactly 2 times and stop when the top dead center mark on the camshaft pulley lines up with the mark on the oil pump. Check to make sure the belt is tight and look at the mark through the cam gear hole. Okay, it's good. Now if you got it wrong, it's not a big deal. Loosen the tensioner bolt, push it down and tighten the bolt. Turn the cam gear forward or back depending on what it needs, and skip the belt over one tooth. Hold the belt on the cam gear and loosen the tensioner bolt so the spring can take up the slack. Only turn the engine clockwise. If you go the other way, the timing belt will lose tension and skip on the pulleys. Go 2 full revolutions and stop when the crankshaft is at top dead center. Check the cam gear and this time it's lined up. My timing cover was oil soaked and broken, so I replaced the lower half. I even bought the original Toyota dust seal. My upper cover was missing the plug. This is available from Toyota Parts Deal. Install the crankshaft pulley washer with the bend facing away from the belt, then the lower timing cover goes in. Install 4 bolts to hold it in place. I used my imaginary torque wrench here. They don't need to be crazy tight. I kept track of the short bolts and long bolts for you. Only the back bolt is long here. The harmonic balancer goes back on next. Always start bolts by hand so you don't cross-thread them. Put the car in 5th gear to make it hard for the engine to turn, then hold the wheel studs with a pry bar while you torque the crank bolt. Now go almost 2 turns clockwise, but stop at the 45 degrees before top dead center mark. This is the position where you should tension the timing belt. Make sure the tensioner bolt is loose, then apply a little bit of pressure to the cam gear counterclockwise, but don't turn it. This will make the front of the belt tight and the tensioner spring will take up the slack on the other side. Torque the tensioner bolt to 31 foot-pounds. Turn the crankshaft just a little bit to top dead center, the 0 degree mark. Check the camshaft pulley again. It's still in the right place. Toyota says to install the upper timing cover and engine mount bracket together and juggle both parts while you bolt them on. There is a better way. Start by installing only the upper timing cover. Use 3 long bolts and 1 short bolt. The upper bolts seem like they're too long, but they're like that because the wiring harness clips into the exposed threads. Don't forget about the bolt in the back of the timing cover. Now lift the engine by the oil pan as high as it will let you. Install the bolts into the engine mount bracket, then force it past the timing cover. You might have to lift the engine a little more. Hold the bracket with one hand and be careful not to smash your fingers as you lower the engine all the way down. Now it will be easy to reach the bolts from below. I tightened them with the ratchet, but there isn't enough room for my torque wrench in here. With the harmonic balancer off, I can torque the engine mount bracket bolts. Reinstall the harmonic balancer, put the car in 5th gear, and hold the wheel studs while you torque the bolt. The top half of the motor mount is called the insulator. It insulates you from all the engine vibrations. Set it in place, then raise the engine up until the mounting bracket touches the insulator. 3 large diameter bolts hold it onto the body. A smaller bolt and a nut attach it to the bracket. Tighten the big bolts and nut to 38 foot-pounds and the smaller one goes to 27. Remember to install 1 more nut under the engine bracket. Now we don't need the jack to hold the engine. Finally, something that sparks my interest. Get it? Because spark plugs? Add a little bit of copper anti-seize to the spark plug threads and gently set them in their holes. Tighten the spark plugs to 13 foot-pounds. That's not very tight. I've never used a torque wrench on spark plugs. That's fine. Add some dielectric grease to the spark plug wires. This will prevent the boots from getting stuck to the spark plugs. Make sure they all snap into place. The alternator bracket is more important than you might think. This old ground cable is very bad. I won't be using that. I'm making a new cable. I think it's 8 or 10 gauge wire. I'm stripping the ends, then crimping on these big battery terminals. Filling the connector with solder will make it so the connector can't get loose and it prevents corrosion. I don't really want a red ground cable, so I wrapped it in black electrical tape, then used heat shrink on the ends. The alternator bracket does more than just hold the alternator. It is also the main ground connection for charging the battery. The place where the ground cable touches the bracket and where the bracket touches the cylinder head are all electrical connections, and they need to be clean. Don't forget to clean the connection at the strut tower. The alternator bracket is held on by 3 big bolts. Clip the diagnostic connector into place, then attach the ground cable to the strut tower. Now it's time to install the alternator. It's case grounded, so we need to clean the places where the alternator touches the bracket. Wiggle the alternator into place and install the long alternator pivot bolt. Snug it most of the way down, but leave it loose so the alternator can move while adjusting the belt. The alternator tensioner bolt pulls the alternator up to tension the belt. You can get the whole kit at AutoZone. The lower bolt threads into the alternator. Leave these bolts loose for now. Connect the power cable and don't go crazy tight on that nut. Remember to plug in the crank position sensor and AC compressor. The throttle cable is easy. Let's do that next. Attach the cable to the throttle body first, then put the threaded part in the bracket. The cable also clips into the alternator bracket and air cleaner. Adjust the cable so the throttle snaps closed and there's a little bit of play in the cable. We're almost done. Let's install the power steering fluid reservoir. Remember to reattach the metal line to the strut tower. The reservoir just snaps into place. These hoses are a tight fit, so I'm making installation easier with dielectric grease. Make sure to buy power steering or fuel hose and not vacuum or heater hose. I'm bending the metal line away from the engine to prevent the hose from kinking. The big hose is 5/8 inch inside diameter power steering return hose. The length is 25 inches. My Tinder dates are fat enough they don't need belts, but the RAV4 does. The power steering belt is first. Get it around the crank pulley, then the power steering pump. Pull the pump away from the engine, then use a pry bar to tension the belt. While holding the pry bar, tighten the lower bolt. You should be able to move the belt about 1/2 inch with one finger. If you got it right, tighten the other 2 bolts. If you installed a new belt, you may have to re-tighten it after a few drives to stop it from squealing. Drop the alternator belt down from the top and make sure it sits on the alternator pulley. Pull the belt over the crank pulley and AC compressor. Spin the belt a little to make sure it's in the grooves. Tighten the long alternator adjuster bolt until the belt feels tight. You should be able to move the belt about 1/2 inch with one finger. If it's good, use a 12mm wrench to tighten the lower bolt on the adjuster, then tighten the big pivot bolt with a 14mm wrench. Make it tight because this is also the main ground connection for the alternator. Let's get that battery back in here. The rear battery hold-down bolt is attached to the battery tray with a bracket. Install 4 bolts to hold the battery tray in place. I tighten these by hand too. Set the battery down with the positive terminal closer to the engine. You'll have to hold the front battery bolt while you install the bracket. Add 2 nuts and don't make them super tight. Install the battery terminals. Gently turn them if you need to, but never apply force to the battery. The battery terminal nuts need to be only tight enough to keep the terminals from turning. And no sparks. That's good news. The only thing left from my pile of parts is the left front wheel. My technique is just sit on the floor and hold the tire up with your feet. Always start the lug nuts by hand so you don't accidentally cross-thread them. Now I'm lifting the left side so I can have both wheels in the air for the next step. The power steering needs some new fluid. Fill the reservoir all the way up, then go inside the car and turn the key to unlock the steering wheel, but don't start the engine. Turn the wheel all the way left, then all the way right, several times. This will circulate power steering fluid through the pump and the rack and get the air bubbles out. I only needed to go all the way right, then left a few times. It actually works much better with the engine off. Top off the fluid, and that part is done. Finally, let's get some coolant in here. I bought pre-mixed green coolant, but if you have red Toyota coolant, you should stay with that. Now let's just start the engine so we can warm up the cooling system and get all the air out. Or maybe not. I guess the RAV4 doesn't want to run after I worked on the engine. I must be an idiot. It ran before I worked on it. Okay, let's see what's going on here. I cranked the engine several times and it still won't run, but the exhaust smells like gas, so the fuel system seems to be working. I used a spark plug tester and found out I have no spark at the spark plugs. I also noticed the tachometer shows 0 RPM while cranking. That sucks because I could have a bad crank position sensor. It's behind the timing cover and it means I could be in for a lot more work. I connected my favorite eDiag scan tool and found out I have a code P1300, which means the igniter circuit doesn't work. The live data stream from my scan tool also gave me 250 RPMs while cranking, so the crank position sensor works, but the tach doesn't. Weird. Let's take a look at the diagram. The igniter is to the right of the coil in the picture. It takes a signal from the computer and tells the coil when to fire. I tested for power and the coil and igniter both had 12 volts. The computer has an RPM signal, but the tach gets its RPM signal from the igniter. The igniter doesn't work. I got pretty aggressive with the pressure washer when I had the car apart, so I checked inside the igniter. No water, but check this out. The igniter gets its ground connection from the case. Every electronic module must have power and ground in order to work. Ironically, the diagram is missing the case ground, and my igniter is also missing the ground in real life. You see, I painted all the brackets blue, and that's why my car won't start. I cleaned off the paint where the igniter bolts on and where the bracket touches the firewall. Let's try it now. Oh, it runs. I thought I would have to change the name of this video to How to Break Your Car and Waste Lots of Time and Money. Now I'll just fill up the funnel and wait for the engine to warm up. You can get some of the air out of the system by squeezing the upper radiator hose. It took about 15 minutes for the engine to warm up on idle. It will slowly spit out air bubbles. Feel the lower radiator hose. It will get hot when the thermostat opens. Once the thermostat is open, coolant can circulate through the whole system and all the air bubbles will come out. Also check to make sure the heater is blowing hot air. That means your heater core has coolant. Okay, that's enough. Let's turn it off. Have you ever had a bad idea and just did it anyway? I didn't catch any of that coolant with my paper towel. That's good because it would have burned me anyway. Put the radiator cap back on and fill up the overflow reservoir. I'm using 50-50 pre-mixed coolant, so it's ready to go. Let's get this car back on the ground. Now I can torque those lug nuts. If the wrench doesn't turn when you're applying 80 pounds of force, you have torqued the lug nut. Remember how I removed the power steering idle up hoses? I'm turning the wheel on idle, and it works just fine. The RAV4 didn't need those extra vacuum hoses. While we're here, check out this pile of parts. Replacing the head gasket is a good opportunity to freshen up the car with all new hoses and seals. Okay, it's finally done. I can't believe it. And congratulations, you've made it through a whole hour of me explaining car stuff. Now I know you have one question left. How much does this cost? I got an estimate for replacing the cylinder head at the tire shop by my house. All the parts needed add up to $1,700. It's 27 hours of labor, so at $110 an hour, that's almost $3,000. Of course, the government has to get their greedy paws in there and steal an additional $300 just in case your car repair wasn't expensive enough. That brings the total to $5,000. Kelley Blue Book value on an old RAV4 is $2,000, so that means a blown head gasket equals a totaled RAV4. Doing it yourself is a much better deal. I saved a lot of money buying parts from AutoZone. I already have a lot of car tools, but I still had to buy a torque wrench, torque angle gauge, harmonic balancer puller, and that fancy mountain wrench. You'll spend around $300 in tools to get the job done. The labor is free since I fixed the car myself, and that brings the total to $1,200. That's much better. Napa Auto Parts has a car repair estimator online. It's pretty accurate, and they give you a list of parts needed. Car manufacturers keep labor hours a secret from consumers, but you can get a pretty good idea from the labor total. Thank you so much for watching, and if you have an old RAV4 like this, definitely check out my other RAV4 repair videos. I have 25 of them so far, and if any of your friends own a first generation RAV4, definitely share the videos with them. Unless you hate them, then don't. Before you go, check out the video description below. I have time links that will help you jump to the part of the video that you need, as well as tools that I've used. That's all I have for now, and I'll see you guys next time.